Today, I'm going to show you how to do a linear regression in Rguroo. It's actually quite easy, but I'm going to use a data set that I found from the repository because it's one that you would have to be able to use. So to get to that, you're going to go to dataset repository under data, select it. It's under Rguroo, under user guides, and then, oh no, sorry, Wiley, we have the serial data set. Okay, you import it. And then once it's imported, it should be in your data set section. You close this out. That's just for getting the data. Now, what we want to do is do a linear regression. So we're going to go to analytics, analysis, and you see that it is already labeled as linear regression and simple regression. Once you get that, you come to another prompt screen. On that new prompt screen, select a data set. I have way more on my set, but look, serial 1, which is a second copy of it. That's why the 1 is in parentheses. Then you need to do your predictor and your response variable. So predictor is going to be your X value, which is your independent, okay? So I'm going to say that the size is independent, and my response is what I think is going to be dependent on that size. So I'm going to say that your total carbohydrates is going to be dependent on the size. And actually, I'm going to say a serving size for the X. If I don't touch any of the buttons down at the bottom, I hit the eyeball to see, and it shows me the scatter plot of the serving size versus the carbohydrates. Okay, it gives me the linear regression line. Now notice it uses the variable names instead of Y and X, but I know that those are the Y and X. You can play around with the details if you want to, or you can play around with the basic. You can add some of the things in. You can do predictions and residuals. You can do the test of association, confidence interval. But for this, we're just going to be doing the linear regression and the R and R squared, which you can find here. So see that the R coefficient is 0.9835. That's very strong. It's almost close to perfect of 1. The R squared, we know that 96.7% of the Y values can be explained by the X values. And then again, we have the linear regression equation here. Now I am going to write this out. I'm sorry that this is not going to be as neat, okay? But remember, total carbohydrates was our predictor, or our Y. You can also see that that is on your Y axis, equals 1.4219 plus 0.784889, and then the serving size was X, and you can also see that that is on your horizontal or X axis. So you can plug in those variables for it. Sometimes you'll see this Y here, sometimes you'll see it F of X, because Y is a function of X. And I can also rewrite the second part to be 0.784889X plus 1.4219. So I can rearrange my equation to look where in the Y equals mx plus b format, which we've talked about before in class. So the M is the slope. So this is my slope. It is positive, and I can see that as my line goes from left to right, as my X values increase, so do my Y values, which means that I do have a positive slope. And I also see 1.4219 is my Y-axis. Now look where it intersects the Y-axis. Notice that this is 30, so it doesn't go to 0. So this isn't actually the intersection of the Y-axis. This is just where the graph stops. If I continued this on, okay, and I continued counting with this, so say this is, it's a little bit more, this will be 25. So 20, 10, 0, I'd be all the way over here, and it would cross the y-axis at 1.4219. Now, it's important to realize that because we've said that mathematically you can always find the y-intercept based off of the equation, but it might not make sense in the context of the problem. In the context of the problem here, you're saying if you have a serving size of 0, then your total carbohydrates would be 1.4219, and that does not make sense in the context of the problem. So you would not be able to use the y-intercept. So this is just a little quick of how to get the linear regressions. Again, I'll show you analytics, analysis, linear regression, simple. That brings you to this prompt. You pick your data set. I've already selected the serial. You pick your predictor, your X variable, and your Y variable. You hit the eyeball. It shows you, and from that, it gives you the linear regression equation, which is also called the least squares line of best fit. It gives you your R coefficient, and it gives you your R squared value.